Assalamu alaikum dear students. We are discussing exercise 5.1. Now the question is, prove the continuity of this function f of x equals to 2x square plus 3x plus 6. Now here this 2x plus 3x plus 6 is a polynomial, and you know that the polynomials are continuous on R, that is they are continuous at each and every point of R. In particular, this polynomial, that is 2x square plus 3x plus 6, is continuous function. Now another question is, we have to prove the continuity of f of x equals to x upon mod x when x not equals to 0 and minus 1 when x equals to 0. Now if we consider non-zero real number, that is x equals to a be a non-zero real number, then at this point or at these points f of x is defined by x upon mod x. So here it is a quotient of two functions, x which is continuous because polynomial, mod x modulus function, it is continuous, and both are continuous at this point, and the denominator is not equals to 0 because mod x is 0 if and only if x equals to 0. But we are considering those points which are non-zero, that is x equals to a where a is non-zero. So this means that quotient of two continuous non-zero functions is continuous, which implies that in particular this function x upon mod x is continuous at each and every non-zero point. Now we will check continuity of this function at x equals to 0. For this we will find the limit of this function at x equals to 0. Now the left limit is limit x tends to 0 negative f of x, which is same as limit h tends to 0 f of 0 minus h. Now 0 minus h is in a point which is less than 0, so this means that not equals to 0. And for this f of x is defined by x upon mod x, that is 0 minus h upon mod of minus h. Now 0 minus h is minus h, mod of 0 minus h is simply h. Now h cancels, we get this minus 1. Similarly, a right limit at this point 0 is limit h tends to 0 f of x, which is same as limit h tends to 0 f of 0 plus h. Now limit h tends to 0 0 plus h upon mod 0 plus h. Now h upon mod h is simply h by h, which is h. So here right limit is 1, left limit is here minus 1. So this means that left limit not equals to right limit, hence limit does not exist at point this x equals to 0. So this function is not continuous at x equals to 0. Now another problems we have to check the continuity f of x equals to ax plus 1 if x less or equals to 3, bx plus 3 if x greater than 3. We have to find the relation between a and b if the function is continuous at x equals to 3. Now it is given that this function is continuous at x equals to 3. We have to find the relation between a and b, or find the condition under which this function is continuous at x equals to 3. Since f is continuous at x equals to 3, this means that limit exists. Now when limit exists means right limit equals to left limit, that is limit x tends to 3 positive f of x is limit x tends to 3 negative f of x. Now which is limit h tends to 0 f of 3 plus h equals to limit h tends to 0 f of 3 minus h. Now for all the points here 3 plus h is greater than 3, so this is defined by bx plus 3, that is b of 3 plus h plus 3, limit h tends to 0. Now similarly 3 minus h is less than 3, it is a into 3 minus h plus 1. Now both are the polynomials, put h equals to 0 in LHS as well as in RHS, so we simply get 3b plus 3 equals to 3a plus 1, or we can simply say that 3b minus 3b 3a minus 3b is 3 minus 1, that is a minus b is 2 upon 3. So a minus b equals to 2 upon 3 is the relation between a and b when this function f of x defined as this is continuous. So this is the required relation or the condition. We have to find the value of the lambda such that the function defined by f of x is lambda into x square minus 2x when x less or equals to 0, 4x plus 3 when x is greater than 0 is continuous at x equals to 0 and at x equals to 1. Now here it is continuous at x equals to 0, so limit exists and the value of the limit equals to the value of the function at the given point. So limit x tends to 0 equals to f of 0. Or we can simply say that limit, when a limit exists, means left limit equals to right limit. That is limit x tends to 0 negative equals to limit x tends to 0 positive, f of x is f of 0. Or limit x tends to 0 negative, f of 0 minus h is limit h tends to x tends to 0 positive, f of 0 plus h. Now 0 minus h is in a point which is less than 0, so put x equals to in this 0 minus h in this, and 0 plus h is greater than 0, so put 0 plus h in 4x plus 1. So after putting these values and put limit h tends to 0, we simply get 0 equals to 1. So 0 equals to 1 is absurd, it is not true. So this means that there does not exist any value of the lambda, such that the function is continuous at x equals to 0. So when the function is continuous at x equals to 0, this lambda does not exist, which implies that it is never continuous, because we assumed here, or it is given that this function is continuous, but we get here 0 equals to 1, which is absurd. So this means that lambda does not exist when f is continuous at x equals to 0. Similarly, it is also given that lambda equal this x equals to 1, the function is continuous. So left limit equals to right limit, because continuity means limit exists. Limit exists means left limit equals to right limit. That is limit x tends to 1 positive, f of x is limit x tends to 1 negative, f of x. That is limit h tends to 0, f of 1 plus h equals to limit h tends to 0, f of 1 minus h. Now 1 plus h is the point which is greater than 1. Here point greater than 1, we have to put in this 1 plus h in 4x plus 1, because this is the required the condition, and 1 minus h is also we have to put in this 4x plus 1, because for all the points which are greater than 0, function is defined by 4x plus 1. So putting, we simply get 5 equals to 5, which is true for each and every condition. This means that if this means that for each and every lambda, this function is continuous at x equals to 1. Hence lambda equals to a, we can say that lambda equals to a is the required the value of the lambda when this when this function is continuous at x equals to 1. So lambda equals to a, where a is real, is the required value. So this means that there are infinitely many values of lambda at which this function is continuous at x equals to 1, but the value does not exist for the function to be continuous at x equals to 0. So inshallah in tomorrow's video lecture we will discuss the composition of continuity of a composition function. So thank you.